Hello? Okay, whatever. All right, so let's see what we have left to do. I actually got your attendance. Okay. All right, so we was over here somewhere. So the thing that they're talking about now is, so we did all this two sample stuff and we did it with proportions, right? Now they're gonna start talking again about means, okay? But the thing is like it matters if the two data sets or the two things that you're pulling the data from are related to each other. So for instance, they start saying like, oh, well, we could have samples that are dependent, or we could have samples that are independent. All right. What would it mean for a sample to be related to another sample? Can you give me an example? And then, of course, what would it mean for a sample to be completely unrelated to another sample? What do you mean? What's a sample? I don't understand. Yeah, that would probably be related because they're all kind of growing up in the same family, so they probably all have similar type of culture, so they probably all drink similar type of stuff, right? Especially as babies or whatever, right? Versus like if we picked, someone from some group of people from that family and we compared it to some random group of people from anywhere. Does that make sense? That really wouldn't be related anymore in any way, shape, or form. We wouldn't expect it to have any relationship, except for the fact that they're all like people. Does that make sense? Um, so they want to talk about whether or not samples are independent or dependent. So it says the effect of caffeine as an ingredient is tested with a sample of regular soda and another sample with decaffeinated soda. And it says determine whether the samples are independent or dependent. What would you say? I would say this seems like it would be pretty independent from each other. Like we test caffeine on one group of people, we test not having caffeine with another group of people. Why are they really going to be related to each other? Does that make sense? What would be the problem is if we set something up with an experiment similar to this and it was dependence. So give me an example. So with caffeinated soda and decaffeinated soda. Yeah, and then why would that be kind of like a problem? A little bit, maybe. Well, give me an example first. What's dependent first? So what are you sampling? What are you testing, etc. Well, what if we had like one group of people and we started randomly selecting a group of people from inside of there to give them decaffeinated soda, and then a random group of people in there to give them caffeinated soda. But then what if sometimes we gave caffeinated soda and decaffeinated soda to the same person or something like that? So first, like, if you take decaffeinated soda first and then you have caffeinated soda, right? Maybe you tell me there really wasn't very much effect from the decaffeinated soda. But what if you took caffeinated soda first and then you took decaffeinated soda afterwards? Like, depending on how long afterwards you took the soda the second time, you might still have an effect from the caffeine from the first time. Does that make sense? Anyway, stuff like that. Does that make sense? All right. The accuracy of verbal responses is tested in an experiment in which individuals report their heights and then are measured. The data consist of reported height and measured height for each individual. So would this be dependent or independent? What would you say? The independent? Which one? Independent? No. So why would it be dependent? So you're pretty much right, but it's not it's like so the thing is like we're trying to see if I'm trying to ask effectively if the sample one would be related to sample two in any way. Does that make sense? It's hard for me to believe that if the measured height for all of these people was like 7 feet tall, that they're going to turn around and start saying they're 2 feet tall. Vice versa, it's hard for me to imagine if someone's 2 feet tall for them to turn around and actually, or for them to say they're 2 feet tall, and then for them to actually be like 5 feet tall. Does that make sense? So people who do lie about their height, but they'll lie a little bit usually, right? Like they'll be like, "Oh, yeah, I'm 6 feet tall," and they're like 5'10" or something like that. But they're not going to usually turn around and start saying they're 6 feet tall and they're 5'6" because it's kind of obvious then, right? So the point is they would be a little related in that case. Does that make sense? Right? The result that so like you're gonna have a reported height. So I ask you how tall you are, and then we measure you. I ask him how tall he is, and then we measure him. They're gonna be related a little bit, the two values. Does that make sense? Right? All right, let's see what this is. Test the indicated claim about the mean of two populations. Yeah, whatever. All right. So then I guess let's do this thing. A researcher wishes to determine whether people with high blood pressure can reduce their blood pressure measured in millimeters of mercury by following a particular diet. Use a significance level of 0.01 test claim that the treatment group is from a population with a smaller mean than that of control group. Use the traditional method of hypothesis testing. Okay, so the first thing we have to do is what? We have to do the null and the alternative, and we have to do the assumptions. Is that correct? So what is my ho and what is my ha? Which mu is less than? What do you mean? You have to say like mu, sure. No, it's definitely mu. This is definitely means. But mu what? Like you gotta tell me like something like I don't know what's two. Oh, two this thing? That this is gonna be less than? No. Why would mu one be less than mu two? Yep. It says that, and then in addition to that, it says also that the medication can reduce the blood pressure, right? So the mean of this group should be less than this one. Does that make sense? So then mu one is less than mu two, right? So then mu one equals mu two is that one, two. Then we always said that we can rewrite this way as well, right? Right? Any question there? What are the assumptions we have to verify? The ha is the thing you want to show. What assumptions do we need to verify? No, we want to prove it's lower or that type of thing, but that's not, what do we have to verify to try and prove that? I mean, like, we don't know anything about the distribution of this stuff. Is that right? We want it to be normal, right? So when is it going to be normal? When the central limit theorem says if we randomly pick a group of people and then the n have the group has to be larger than 30, then these averages are going to follow a normal distribution. Is that correct? So in other words, all we have to do is check if this is greater than 30 and if this is greater than 30, and it is. Does that make sense? Okay, so that's that. All right. Now we start saying then that like we want to look at the average of this one minus the average of this one, let's say, because that's what this says. Does that make sense? So x bar one minus x bar two, they're both going to be normal, right? But we don't know the standard deviation for each one. Does that make sense? So this, we can't do normal here, okay? But we know it would be normal. The mean would just be mu one minus mu two. The standard deviation, though, we don't know. So when we don't know the standard deviation, we start using the t-distribution. The standard deviation we said would be equal to the square root of the first one squared. Plus the second one squared. Okay? Because s over square root of n. Does that make sense? Well, I mean, that's not really that hard to do on your calculator. Does that make sense? All right. So we're gonna have to do that in a second, so I might as well just do it now. So what do we got here? So we gotta do square root of some stuff. So 17.4 squared, right? Divided by 101 plus 30.2 squared divided by 105, I guess. Does that make sense? Whatever that is. Okay. What do I put for, okay, so this part I know what the answer is. Oh, sorry. I should say something about the degrees of freedom here also. The degrees of freedom. So there's good some formulas we can use to actually calculate it and get a better answer for what these things are, but they don't really usually care. So what you want to do is you just want to say that the easiest way to say it is usually just say, if you pick the one of these that's the worst, the one that's worst, that's the one you can select as the degrees of freedom because that's the most conservative way to estimate it. Okay. So which one of these two is worse? Well, I'm asking you. No. The treatment group is smaller. If you have less stuff, it should be a worse estimate. Is that correct? So then, because that's going to be the one that I'm more unsure about. Does that make sense? And the degrees of freedom has to do with how like unsure you are or something. Does that make sense? So then this thing, 101. So we would just say that the degrees of freedom we could pick as 100. Right? One minus that. Sorry? Just if you sample less things, you have a worse estimate for what you're getting, right? If you sample 5 people versus sampling 50 people, like I don't think you're really gonna trust the 5 people result that much. Does that make sense? Question with this so far? All right, what's the mu1 minus mu2 then? Because we need to know what the average is. So what is that? Sorry? 4? How many, what? Well, you tell me. That's why I'm asking the question. So mu1 minus mu2, mu is the parameter for the distribution, right? Do we have any idea what the mean is of the treatment group for the overall thing? We have no idea. We have no idea what that is. Does that make sense? This is just the sample estimate. Is that right? So we have no idea what this is. We have no idea what that is, right? So am I going to be able to say what this is? Yes. Because right here it says mu1 minus mu2 has to be 0. Does that make sense? That's what we're assuming. Is that right? If you assume the two groups are equal to each other, then you're assuming the mean from the first group minus the mean from the second group is 0. Is that right? So this part is 0 in this case. Is that right? Okay. Second part, we have to do a test statistic, right? Right? What does that mean again? Mm, what is a test statistic though? Z value or T value in this case, which is what? What does that mean? Number of standard deviations. So then this is, so what's the mean in this case? 0. What's my sample estimate? Like, what do I have to plot on here? This is standard deviation. What am I comparing to 0? This is alpha. X1, what do you mean? What does control group mean? Why do you even have, what does control group mean in general? Like, what is that? What does control mean? But doesn't have the treatment. Why would you, why would you want to do that? Why would you want to, yeah, because the people without the treatment, like, we need to know what their blood pressure is normally, right? To see if the treatment actually did anything or helped. Does that make sense? Right? I mean, like, I don't know. Maybe if we don't compare it to something, like maybe if I just say, hey, 20 years ago, this was people's blood pressures, and now I check the blood pressure of people's now, like maybe it just got lower. You know what I mean? Maybe it just got higher, whatever. Does that make sense? But that wouldn't really be a good idea. Like, I should be comparing it to people that are around right now. So we take one group of people, we test them with this thing. We take another group of people, we don't test them, and we compare the two. Does that make sense? Okay. So what am I going to write here to compare to 0? I mean, if I'm going to do anything, I have to compare the 120.5 to this number. That's the whole point of having that. Is that correct? Right? I'm not going to compare this to 0. Is that right? So our sample estimate here, you should be telling me we should have to calculate this. Is that correct? What is that? Now what? That's the number that I need to plot on here somewhere. We need to see if that observed difference between these two things is large enough for it to be significant. Does that make sense? So we compare that to 0, because if it was 0, then this treatment didn't work. Is that right? Does that make sense? Yes? All right, so Z is equal to X bar, oops. It's equal to X bar 1 minus X bar 2 minus mu 1 minus mu 2 all over whatever the standard deviation is. Oh, sorry, we're not doing Z, we're doing T. T, and this is S1 squared over N1 plus S2 squared over N2. All right, well, I don't feel like writing out all these numbers again. So the numerator is just what? 120.5 minus 149.3. So take this and divide this by this. Does that make sense? We got that, it looks like. Negative 8.4256, I think I got. And I mean, I think that kind of makes sense. Like you got 100 people here and their blood pressures seem to have gone down actually a lot. Is that correct? Right? There is a pretty big standard deviation for these things, but they did sample a fair amount of people. Does that make sense? All right, so now we have to calculate the p-value. How do we calculate the p-value in this case? Can't do normal. Why not? TCDF, we can't do normal. Does that make sense? So if we, I'm just gonna go here and do it this way first, actually. Two sample t-test. X bar 1 is 120.5, 17.4101, 149.3, 30.2, 105. We wanted to check if it was less than. Let's get the same number here. Does that make sense? It says the p-value is 0. Okay, it's not actually 0 though. All right. I just wanted it to give me its degrees of freedom here because it gives me a better estimate for what the degrees of freedom are. All right. So this is 167.43. Does everybody see that? I'm going to use that. Okay. So if I use TCDF, the lower in this case is negative 1.99. The upper is whatever this value was here, right? So that was this number. Does that make sense? This area here. Does that make sense? Uh-oh. Oh, I typed the wrong negative. I always do this wrong. You use that one, right? Still says 0. Okay. It's more than 8 standard deviations away. It's tiny. Is that right? It's not actually 0, but it's very small. Does that make sense? So the p-value in this case is approximately equal to 0. Okay. What does that mean? Sorry? Okay, yeah. So what does that mean? Reject the what? reject the null hypothesis. So what does that mean? There's sufficient evidence to support the alternative hypothesis is correct. Good. But just say that in words, okay? So there is sufficient evidence, you said, to support the claim. What? What do I say? The treatment, yeah, but you lowers blood pressure, like, eh. You're not saying this part here, average. We're trying to show that the treatment group has a smaller mean than that of the control group. Is that correct? So say that. There's sufficient evidence to support the claim that the treatment group has a smaller mean than that of the control group. That's what they wanted you to show. Is that correct? Question? All right. How would I do this with a confidence interval? No. So where does the rejection region go in this case? The center? It can't be both sides here because we're only trying to show it's less. So it has to be only on the left side. Is that right? The center. You sound like this guy over here. The tip. So then the this one. So then this here, you had to take the alpha over there. Alpha would go over here, and we have 1% there. Is that correct? Okay. So then what size confidence interval would we be able to 0.98? Does that make sense? Because 99 can't fit there. Does that make sense? All right. So then this so we would need a 98% confidence interval in this case. Does that make sense? All right. So then here, go to stat tests. Now, again, all I do is pick the two sample stuff. And then in this case, we're doing T. Is that right? Does that make sense? All this crap, it's going to know it's related. Is that right? The only thing it doesn't understand is what the confidence level is. So I have to tell it that part. Okay. Question? Now this, if you know what we're calculating a little bit, should make a lot of sense. So we have those two things, right? So what conclusion would you draw? Well, I would reject the null hypothesis. It does not seem like this is going to be equal to 0 at all. It's saying the subtraction of these two things is way negative. Is that correct? Does that make sense? So would it seem like mu1 is less than mu2? Well, saying mu1 is less than mu2 is the same thing as saying mu1 minus mu2 is less than 0. And yeah, this is less than 0. Is that right? Question? Does that make sense? All right. Hello. A researcher was interested in comparing the amount of time spent watching TV by women and men. Independent samples of 14 women and 17 men were selected, and each person was asked how many hours he or she watched television during the previous week. The summary statistics were as follows. The following 99% confidence interval was obtained for mu1 minus mu2, the difference between the mean amount of time spent watching television for the two women and the mean amount of time spent watching television for the two men. Now, note though, these numbers are less than 30. Does everybody see that? You can't really say these are normally distributed necessarily here. Okay? But they just tell us this is the confidence interval. Do you understand? So we just go with whatever they say. What does this confidence interval suggest about the population means? What would you say? Sorry? Eh, %99 confidence interval means that 99% of the confidence intervals would contain the true population rate. But what does this suggest about the population means? What would this suggest to you? Again? Is lower than what? Doesn't make sense. What would we usually be trying to, well, what are they trying to test here? That's not what they're trying to test. We never try to test if it equals 0. We try to test either if it's less than 0, greater than 0, not equal to 0, right? The confidence interval says that the mean that mu1 minus mu2 could be 0, right? So what does that mean? That means you can't really say that there could be a difference between the two means. Does that make sense? So you said that you think that the difference would be small or something like that. You can't say how big the difference would be. Okay. We would just say that this does not show that there really would be a difference. Does that make sense? So if you had a null hypothesis and some alternative, the alternative would either be the mean is less than this one, the mean is greater than this one, or maybe in this case, they would do this, not equal to. Does that make sense? They're just comparing them. So then the null would be that. Is that right? Which is mu1 minus mu2 is 0, right? Well, yeah, it still could be 0. Is that correct? So we would say, what is this confidence interval? We would say that there is um not, it does not suggest, it doesn't suggest that there's a difference in the amount of time women watch TV compared to men. Does that make sense? Does that make sense? Question? This is really the exact same example we did the first day where we talked about like the Hillary and the Trump thing. If we say the differences are somewhere between like -2% and 4%, well, it still could be 0. So the difference between these two things still could be 0. So I can't say that there's a difference necessarily. Is that right? Does that make sense, guys? Yes? No? Question? All right. A paint manufacturer made a modification to a paint speed of drying time. Independent samples of 11 cans and 9 cans were selected. Drying times and hours were recorded. Summary statistics were as follows. 98% confidence interval was obtained. The difference between these things. What does this suggest about population means? Say. I mean, I think you can say more than that. What would they be trying to test in this case? You should always be determining what is your null and what is your alternative, right? What would they be trying to test here? Read it. What does it say? Nope. Why? They want to see if it's faster, right? So then this one has to be less time, right? So then that would mean like the B should be less than the A, I guess. Is that right? Right? Okay, so then this is the same thing as saying mu A minus mu B is 0. This is the same thing as saying mu A minus mu B is greater than 0. Okay, so how does that help? How does that help? How does that help? Answering the question. We still haven't answered the question yet. Mean what? What do you mean? Why would this mean that the drying time is lower? So this says mu A minus mu B needs to be greater than 0, right? That is saying that the drying time needs to be lower, but I don't think you guys are actually doing any of the subtraction to see what any of it actually means. So like if I say that you have the mean of this one, you have the mean of this one, right? Then if this one is lower, right? Then the mean of this one minus the mean of this one should be positive. Is that correct? So that's what this says. This says the mean of this one minus the mean of this one is positive. Is that correct? So it supports that conclusion. Does that make sense? It doesn't say that this is happening. It says when you subtract these two things, it's bigger than 4.9. So that means this one's bigger than this one. Is that right? Does that make sense? So there is evidence to say the drying time reduced. Does that make sense? Does that make sense, guys? All right. So the next part about all this stuff now starts talking about like if so those they're kind of done now with the independent samples. So now all they want to talk about now is uh dependent samples. Sometimes people call this, or the thing that we're going to talk about here, matched pairs. Okay, so we'll talk about what that means. So like an example of this Like I remember they would always talk about like an example where, so if I said like you had just a group of men and a group of women that you randomly selected, okay? And then you had like the height of the first one, the height of the second one, the height of the third one, the height of the first one, the height of the second one, the height of the third one, etc. All right. And you had a certain many of each of these. Does that make sense? Like it's not like I would expect this one to be like related to this one in any way. Does that make sense? They're just random groups of people, right? But maybe if we started saying that these were like couples, okay? We randomly picked a bunch of couples, and there was the let's say we had a man and a woman in the couple that we were picking randomly. Then the first man, there would be a height for that first man. There would be a height for that first woman, and there would be a height for the second man, and there would be a height for the second woman, right? But like these are sort of like related to each other a little bit now because they're couples. Does that make sense? Like, could the two people in the couple have very different heights from each other? Of course they could. Okay. But most of the time they won't. Does that make sense? And on top of that, rarely will you see that the woman's height will actually be larger than the man's. Does that make sense? Now, like my mom was taller than my dad, but I think that's like the only person I know who was like that. Does that make sense? You know what I mean? So my point is like if these were couples here, then this would be what we refer to as dependent. And then in this case, these two groups were really just completely independent from each other, coming from like completely separate populations with no relation. Does that make sense? So what they want to talk about now is this stuff now. Okay. So effectively, there's going to be like two samples we're getting, but now the two samples are dependent. They're related to each other in some way. All right. So then what we start saying is like, let's say there's X and there's Y, and you have like X1, X2 up until Xn, and then Y1, Y2 until Yn. And these are somehow related to each other now, each of these pairs. Does that make sense? So they start calling it matched pairs because these things are like matched. Does that make sense? Now, the good thing about this is that we can actually stop doing anything with the two samples and we can start sort of treating it as one sample. So what they do is they start constructing a new variable. Let's say we call it D or something for difference, all right? So let's say I want to say if there's a difference between group 1 and group 2, right? Let's say you have, this is the amount of money that the man has. This is the amount of money that the woman has in the couples though. Does that make sense? And then I just want to see if the man has more than the woman or something. Does that make sense? So what do I do? Subtract. Is that right? So I'm going to do like x1 minus y1 and x2 minus y2 and all of this. And then this becomes the new distribution. Does that make sense? But we've taken like effectively the two samples and made them into one sample. Does that make sense? Does that make sense? Yep. Yep. You okay? So then the now when we do this, the null hypothesis in this case, we're usually going to assume, it's not always going to be the case, but we're usually going to assume that the mean difference between these two groups is 0. Okay? We would want to try and prove maybe that the mean difference is greater than 0, less than 0, or not equal to 0. Does that make sense? We're not usually gonna have sigma for any of this stuff, and in this case, we won't have sigma either, all right? So we're gonna always use t-distribution for these. Okay? So if this thing has some sort of standard deviation and this one has some sort of standard, oh, we're not gonna know these, excuse me. If we have some standard deviation from this group and some, we don't even need to do that either, actually. Once we have this here, we have our new data set. Does that make sense? This data is either normally distributed or not, right? So if n is larger than 30 here, it's going to be normal, the average. Does that make sense? So then they start naming things like this. They start saying, what is d bar? Okay? That's the average of this. Does that make sense? What is SD? That's the sample standard deviation of whatever this is. Does that make sense? Okay. Again, this is referred to as matched pairs. All right. All right. So let's see if let's do this one here. Does that make sense? All right. First, I'm gonna like do it by hand, and then we'll do it on the calculator. There's so few data points here, we can do it by hand pretty easily. Does that make sense? So we could just say, what is D here, right? Well, let's let D be, I don't know, A minus B. Does that make sense? So I don't know what this is. 44, 43, 41, 38, 39. Does that make sense? Then D bar has to be the average of all this crap. Does that make sense? What is this? 80. 82 is 162. 162 plus 43 is 205. 41. Is that what you got? Huh? 173.8. Huh?
Oh, no, divided.
It's 205 anyway. How do you get 173.8?
Oh, you're wrong.
41. Does that make sense? All right. All right, so that's the answer. Any question with that? Don't forget though, I mean, like, I shouldn't really have to tell you this because we did it before, honestly, also. But oops. I mean, you could just type these in here. I don't really suggest to do this with this. It takes longer to type it in. You'll probably make a mistake doing it. If there's a lot of things, I don't even know. I still wouldn't do it. This, we could do this L2 minus L1. Whoops. Sorry. L2, excuse me, minus L1. And then it gives you the same thing. Oh, I did L2 minus L1. I did L1 minus L2 here. Does that make sense? All right. It says SD. The differences between these two sets of dependent data are as follows. Find this. How would you do that? What did we just say that was? What is S? Sample standard deviation. So how do we find that? Just run the first test. 1 var stats. None of you remember to use 1 var stats? Yeah. Does that make sense? Question with this? All right. Assume that you want to test the claim that paired data comes from a population where the mean difference of this is 0. Compute the value of the test statistic. Okay? Does that make sense? Let's just do the whole thing. Now, again, this should be easier because what's going to happen now is this is going to be back to having like one sample again. So this is going to go back to the way we were doing stuff really from chapter 8. Does that make sense? Okay. So they said they wanted to test whether or not mu d is equal to 0. So that means the alternative is mu d is not equal to 0. Okay. They didn't give us a alpha level because they just said to get the test statistic. Okay. So first thing I gotta do is type these numbers in because this one, I don't want to calculate everything out. So this one's going to be L1. So what do I type? 8.1, 5.2, 5.4, 8.9, 4.4, 12.1, 8.9, 6.2, this one is 6.3, 4.9, 6.5, 4.2, 4.8, 0.89. Okay. So we have to construct the difference variable, so we take the difference. Does that make sense? So, I mean, you could just do this, right? 1.8, 0.3. I didn't have to really type these in. Does that make sense? So this is going to be what? L1 minus L2. This, right? Okay. Now we can get the statistics for this thing. So I can just go to stat calc, 1 var stats, L3. Does that make sense? So then this means the sample size was 8, X bar was 2.025. The sample standard deviation is whatever this is, 2.39568. 2.39568. Does that make sense? So they said compute the value of the test statistics. So that means that they think that these come from normally distributed populations. Does that make sense? Does that make sense? They would usually have to tell you. okay? So we can assume that these things are normal here, I guess. So then if we do, then their difference would also be normal between them, all right? So now we have a normal distribution. With the mean equal to 0. The average we observed is 2.025. Does that make sense? We want to see how many standard deviations this is away, right? You understand? The standard deviation here is this over square root of this. The degrees of freedom is n minus 1. All right, so t in this case is going to equal to x bar minus the mean divided by s over square root of n. X bar in this case is whatever this was, 2.025. The mean is 0. The standard deviation is this thing, 2.39568 divided by square root of 8. Does that make sense? All right, so we get that number, 5.9169. Okay. Now to calculate the p-value in this case, the p-value is going to be equal to, we have to do the area of this region here, but since it's a two-sided test, I have to double it, okay? We talked about that before, right? So then this is 2 times TCDF of whatever that T value is, 1E99. Degrees of freedom is 7. So this is whatever we were just calculating. 8 or 5.9169. And this is approximately equal to 0.29468. Oh, I didn't multiply by 2. 58935, sorry. Doesn't really matter, it's small anyway. So this would mean that we would reject the null hypothesis that these things are the same. We would say that there does seem to be a difference between the two things. Does that make sense? Okay, now, how would you check this with a confidence interval? If we were taking alpha to be 5%, what size confidence interval would I need? 0.9 is correct. So, no, 0.95. So then if this is 5% here, this is two-sided now, so this goes on both sides. 0.05 total on both sides, right? 0.025 on both sides is correct. So then this means this would be 95%, right? All right, let me just do the whole test out on the calculator. okay? Because you could do this on the calculator, of course. So stat tests, which test would I pick? Nope. We made it into one sample. Is that correct? So we're gonna have to just do t-test, okay? T-test. Now I have the data. Is that right? Let it calculate it for you. The mu naught, that's the mean in the null hypothesis. Well, we're saying it's 0. The list, oh, I put that in L3. Does that make sense? Does that make sense? Frequency, whatever, this not equal to, calculate. Whoa. What happened here? I got a very different answer. 2.39, that's right. That means I typed this in wrong. That's not good. I gotta do this again. What happened here? 2.025, I swear I typed this before. Divided by, I even wrote parentheses, I remember. 2.39568 divided by square root of 8. Huh. I don't know. I don't know what I did before. Weird. All right, this number here was wrong. This number should have been 2.3908, it looks like. So then this is going to change here. Does that make sense? Then it's going to be 2 times TCDF. Now this number was wrong, right? So it's 2.3908 should be fine. And then we get that, I guess. 0.048. It's much closer actually to being rejected now. Still have the same conclusion, so we got lucky there, I guess. But coming back to here, sorry. All right, now I have the same numbers. Does that make sense? Still have the same conclusion, okay? Now if we go and we do the confidence interval, I'd have to pick T interval, one sample. Does that make sense? This we said was what, 90, I believe, right? 95 is correct, sorry, thank you. Now we get this, 0.02216, 4.0278. So now we think that the mean difference is between these two numbers. But that definitely means it's positive. Does that make sense? So it would seem like this one, not equal to 0. 0 is not in this interval. Does that make sense? Zero is not in this interval. Does that make sense? Question? Okay. Determine the decision criteria for rejecting the null hypothesis in the given hypothesis. As describe the values of the test statistic that would result in rejection of the null hypothesis. Suppose you want to test a claim that the mean value for the difference of D for a population is different from 0. Given a sample of n is 23 and a significance level of alpha is 0.05, what criterion would you use for rejecting the null hypothesis? So not equal to 0 would mean that there would be we could reject on either side, right? Right? Then if alpha is 0.05, then this part is 0.025, and that part is 0.025, right? So we need to find out what that position is there and that position is there. If n is this, the degrees of freedom is 22, right? Right? So then I just go on the calculator and I do inverse t, just like we were doing inverse z before, right? So inverse t, the area here is, I guess, 0.975. Degrees of freedom is 22. So you get a 2.0739 and negative 2.0739. So in other words, if t is greater than 2.0739 or t is less than negative 2.0739, we would reject the null hypothesis because it would be far enough away. Does that make sense? That one should be kind of similar to what we were doing before. Does that make sense? Right? Construct a confidence interval mu d for the population difference, assuming that the paired thing. So this one's actually pretty easy. This one's not nearly as hard as some of the other things. Because they're just asking me the one part. So all I really have to do is do the subtraction with these things, do a confidence interval. Now you can do the subtraction pretty easy. Is that right? Does that make sense? So then I just type it in. All right. And then I do 90% confidence interval. So I go to test, t interval, L1. That's it. Does that make sense? Question? Question? All right. Using the traditional method of hypothesis testing, test the given claim the mean of two populations. Assume that the two dependent samples have been randomly selected from normally distributed populations. All right. What do we have here? I mean, all right, so there's gymnasts, 7 gymnasts randomly selected, and their competition scores were recorded before and after training. Use a 0.01 to claim, test the claim that the training technique is effective in raising the scores. Okay. So then, I don't know, I'm going to do like this one minus this one. Does that make sense? So then I want to say that the mean is positive. If I do after minus before, then I'd want that to be positive if the training was effective. Is that correct? So I construct that variable first. So that's what? 0.1, 0.2, 0, negative 0.1, 0.1, 0.3, negative 0.2. Does that make sense? And then you pretty much just do the same thing. So it's the same thing as doing t interval or t test or whatever from chapter 7 or 8. So then this is 0.1, 0.2, 0, negative 0.1, 0.1, 0.3, negative 0.2, right? One sample, does that make sense? Every time you do these, it's T, okay? So stat test, T-test. I type this crap in L2. Do you understand why I'm making this 0 here? So we get this. That's a pretty big p-value, actually. Does that make sense? So we have T 0.8799. And the p-value is approximately equal to 0.2064. Now, like, I don't know about you, but like, if you just look at these scores, like, I don't know, did the dude really make that much of a difference? Not really. Does that make sense? The test should say that also. Is that correct? Otherwise, it's stupid. So then this thing is not rare enough. Is that correct? These differences could be observed just by chance, we're saying. Does that make sense? So there is not significant evidence to say the coaching was effective. Does that make sense? What size confidence interval would I need to select if I wanted to do this using the confidence interval method? What did you say? What size confidence interval would I need to select? Where would the rejection region have to go? On the right is correct. If this is 0 here, then we want to show it's greater than 0. That would be the only place you could do that. Is that right? So then that area there would have to be 1%, right? So then what size confidence interval? 98 is correct. Right. So then we go to stat test T intervals number 8. Data, this is still the same list. Again, this is the only part we usually have to change here, right? So now we get this. Does that make sense? Now this is saying that the difference is somewhere between here and here. Like it still could be 0. Is that right? This doesn't mean that the coach is doing great. Is that correct? If these are all positive, then it would be good. Is that right? Does that make sense? Question? Excuse me. All right. Last question. It's kind of exciting. This is kind of exciting. That's the last one. No. The only other thing we have to do is the review. I mean, there's no more content that you have to go over. That's what I'm trying to say. Like, you don't have to go learn more stuff. Does that make sense? All right. So then you want to get rid of us. All right. So then the 95% confidence interval for a collection of paired samples is this thing. Based on the sample, a traditional hypothesis test fails to support the claim of mu d greater than 0. What can you conclude about the significance level of this hypothesis test? But this says it fails to support the claim. What does that mean? I mean, this looks like you would reject the null hypothesis. Is that correct? But they're saying that the 95%, someone made a 95% confidence. But then someone did a hypothesis test also, someone else. Okay? They're not saying that this 95% confidence interval solves the problem for the hypothesis test. It obviously doesn't. Is that correct? So then what does that mean, though? So what you'd have to say is that you'd have to say that like the alpha level for the thing is definitely going to have to be less than 0.025, not equal to 0.025. The reason being is that if the confidence interval here so the 95% confidence interval that they constructed, right, ended up being between 0 and 3.4. That means this is like approximately 0.025, and that's approximately 0.025, whatever, right? But then they say that this one failed to support this thing. Is that correct? Right? What does that mean? That means that it couldn't say it's always greater than 0. So that means if you did the right size confidence interval, right, it would actually have to have 0 inside of it. Does that make sense? Does that make sense? Well, then the problem is that like for the only way to make that size confidence interval would mean like this would have to get bigger here, and that would have to get bigger there, or like those would have to go further away, right? In other words, these areas here would have to be smaller. Does that make sense? So it'd have to be less than that. Does that make sense? Do you get what I mean by that? Does that make sense? Another way you could say it is like someone made this confidence interval and it's going from 0 to 3.4, and then someone else is saying it's wrong, right? Well, like those people had to be like the second group of people had to be like more careful. Does that make sense? Right? They're like your estimate wasn't good enough. They were trying to be more careful. Does that make sense? So then if they were trying to be more careful, they would have a lower alpha level because that's harder to reject the null hypothesis. Does that make sense? Question with this? So try and draw these pictures. The pictures help. Okay. All right. Now, let's just do it next time. So next time we will do the let's see if this is what it says for the answer here. Yeah, they say the same thing. Okay. Next time we will do this. So I strongly recommend you bring it to class, first of all. Second of all, I would advise you to try and do it before next class meeting, okay? Otherwise, what I'm doing is not really going to be that helpful, because usually I do this closer to when your final exam is. Does that make sense? So then, if you go to the classworks here, and then you click on this one, right? Yes. That's correct. That was tough. All right, so then no, but this thing, okay? You'll see some of the questions are from stuff from the beginning. All right, so they shouldn't really take you very long. I don't remember, I think it's 40 something questions. 47 it looks like. Okay. Finals, like not for, yeah, finals the last day of class. I don't remember what that is. Like after, I think it's after Thanksgiving break or sometime, right? Yeah, in person. So then the the 30th. Okay. All right, then this, and I mean that you have to be here on time and all that, okay? No, I'm not saying nothing. No, nothing. Nothing to say here. So then no, but this, do it yourself, okay? I'm gonna do it again in here, but then you can actually see what you have questions about. Does that make sense? Plus, this is a good review for everything. Okay? Question? And I will record it also. All right? All right? So we'll do that next time. So please print that and bring it. And definitely, if I were you, try and do it beforehand.